the solution part here. First we need to go to find the bracketing solution, right, that by the random check method. And once we get this bracket, this solution, then we can go for the iterations, right. That iteration will go with the help of this formula that gives the actually bisection method. Okay, so once you get the value of a and b, you can apply this formula, that is a plus b by 2. You can see this is the bisection of the range. Okay, and that value whatever you will get, that is the answer of the first iteration. And according to the requirement of the question, we have to go for the number of iterations, right. Now let's check what should be the flow chart. Okay, what should be the flow for the programming. So first we will start and we will define the function. That function will be in the form of y equals to f of x, right. And then we'll go for the random check to get the value of a and b. Okay, so this will give the approximations root, right. And we can define that what should be the number of iteration if it is given in the question. If it is not given, we can go with the error also, that how much error is permissible to get the root. We will have two programming here. First will be based on the number of iteration, that is n, and second will be based on the error, that what is the permissible error to get the best root of the given equation. Okay, after that, if what we have to do, once we get the value of a and b, then we need to check that what is the value of f of a and what is f of b. As we have the common practice that a, whatever a we are getting, that gives the negative value of f of x, right. If f of a is negative, then we used to take that value as a. If f of b is positive, then that is b. Okay, so this is our common practice as we have discussed in that lecture. A will be with the negative of f of x, b will be the positive of f of x. Okay, so if f of a into f of b is greater than 0, that means what? That f of a and f of b both are positive. If both are positive, then it is not our required bracketing solution. Okay, if it is greater than 0, then means we cannot get the solution here. So what we will say that if it is yes true, then given approximate values do not bracket the root, right. Now try again with different values. Then again we will come back to this portion. Again we have to give the value of a and b, and it will check that whether f of a into f of b is greater than 0 or not. Okay, this loop will go in continue until we will get the desired value. What is that? The set of f of a into f of b is less than 0. Okay, when f of a into f of b will be less than 0 means what? Either the value of f of a is negative or f of b is negative. Okay, once we get the bracketing solution of like this, then we can go for our actual solution. That means this condition will be false. Okay, so we will go to this link, right. So we are moving for the bisection method. So till this stage we have discussed that how to get the value of a and b, that is the bracketing solution, using the random check. And once we get the value of a and b, then we will go for bisection method. Okay, what is bisection method? Here we got the value of a, value of b. Now you can define the number of iteration or the permissible error, and after that you can have the value of x by applying the bisection method, that is a plus b by 2. Now check what is the value of f of x. If it is less than 0, means again giving the negative value. So a should be replaced with the new x, whatever you got with this iteration. Okay, and if it is not less than 0, that f of x is not less than 0, then the value of b should be replaced. So this is the only concept what we use in bisection method. Okay, and this number of iteration we will keep on going as the question is asked, and then final whatever value we are getting for x, that is our required root. Okay, that will be the end of the programming, right. So this is the complete flow chart related to bisection method. Now we are going to have the first numerical problem on the Python programming. So what is the question? That perform 5 number of iteration of the bisection method to obtain the root of this given equation. This is my given equation. Okay, so check the sum to the b. See, the first part is what? That you go for that the right. See. Right, so what we have to do first, we have to define the given function. That is, so what we have to do first, we have to define the given function. Okay, so what is the procedure for that? That def, this is the syntax for defining a function. My function is f of x. Okay, colon. Now what is the function here? if I am writing f of x, then what should be written in that function? That is x cube, right? The function is x cube minus 5 into x plus 1. This is my given function, right? Now after this, what we will do? I need the value of a and b. Okay, so we can have the value of a and b by taking the input from the user. So suppose value of a I need to get first. So a will be equals to input. Okay, this is the syntax to get the value from the user side. And what I want the first approximation root. Okay, you can write the enter the first approximation root. Similarly, I want the value of b, right? So again in the similar process, that is input, the second approximation root. Okay, now first question was about the number of iteration, that it should go for the 5 number of iteration, right? So I will have one more input, that is number of iteration, that how much number of iteration do you want. So again we need to take it in input. So what is that? That is number of iteration. Okay, so this is the input we have taken, right? Now what was my next step? That I need to check for f of a into f of b. Okay, if it was greater than 0, then we need to check for the next approximate value. That means the bracket solution, whatever we have given for a and b, that was wrong. Okay, so I'm going to apply the if condition here, that if f of a, right? So this should be taken as a small f because we have defined here with a small f. Okay, so f of a into f of b is greater than 0. Check for this, right? Then print. If it is true, then what? Then print the that given approximate values do not bracket the root. Okay, so given right. Now what I want, that the user should give the another value. So try again with different values. Okay, so if this condition is true, that is f of a into f of b is greater than 0, means both value is positive or both value is negative, right? So that given solution is not the correct bracket of the root. Okay, so we need to have the another guessing. Okay, so it will be keep on repeating as we have seen in the flowchart until we get the desired output. And if we get the desired output, that means what? F of a into f of b is not greater than 0. That is the else condition. So what should happen? Then we should go for the, we should enter for the bisection method, actual bisection method. Okay, so here I am writing it like this. Now what is this? Here this is the bisection method. I am going to define now, where I will give the value of a and b that we have given here and number of iteration, right? So the bisection method will work for these 3 variables. Okay, so now let's define that what is the bisection method. So because that is the defining part, so I'm going to define it here only. So again the definition, defining a function with the name of bisection. Okay, and we are having the variables as a, b and n, right? So what I have to do here, see, I need to go for the number of iteration of n. Okay, n number of iteration I need to go, right? So for that we can go for the for loop, where we will start with the first number of iteration up to n we can go. Okay, but I am going to write a common program in which you can have any type of condition, whether you need to go for the number of iteration, you can go for the error finding, you can go for the number of decimal places matching, you can define any of that according to the question with the help of this common program. Okay, so for that what I am going to do, I am using a condition statement. This will be by default taken as true, Okay, and I am using the while loop, right? So while condition means by default this loop will be true and it will be executed, right? So after execution, what I want, I got the value of a and b. So bisection method means what? That is x equals to the a plus b by 2. This is the bisection method. Okay, so with the help of this I'll get my first root of the first iteration. Okay, so this is the first iteration value. So here I am going to check that what is the value of f of x. So again, using the if statement, that if f of x is less than 0. Okay, if f of x is less than 0 means what? It is showing the negative value. So x should be replaced with the value of x, right? And if it is not like that, that is else, if f of x is not less than 0, then the value of b should be replaced with x. Okay, this is the actual programming related to bisection method. Okay, so this will be the execution for the bisection method. Now I need to define what? N also, that we have to go for the n number of iteration here, right? So what we have to check, that if the loop is going for n number of iteration, then the execution should be stopped there. That means we should have only that much of number of iteration, right? So I am going to define here one more variable, that is I. Okay, and by default I am going to take it as 1. So I will be equals to 1. Okay, and if here, if I is equals to n, a comparative statement, I is equals to n, then what? Then condition should be taken as false. Okay, that means we have done with our number of iterations, right? If condition is false, then again when it will go for the loop execution, then condition will be false, then there will be no execution. So up to n number of iteration only we will have the executions. Okay, so if it is I is equals to n, then the iteration will be stopped. Else, what is the other condition? That if I is not equals to n, then condition should remain as true. Okay, and the value of iteration should be increased by 1, right? So this will keep on the loop up to the desired number of iteration. Okay, and I want some values in the execution. So suppose I have to print the value of number of iterations. So iteration So I am going to have the number of iteration, the value of x and f of x in the printing set for each iteration. Now after completion of this loop, that means we have completed our required number of iteration, then what? Then I want the printing of the actual answer. Okay, so here I am going to print the actual answer. That means what? The required root. So required root is, what is the required root? That you will get in the value of x. Okay, so that will be printed through this, right? So this is the complete bisection method what we have defined using the DEF syntax. Okay, so this is the complete programming we have taken. Now before going to the execution part, we need to check one more thing, that we have taken the input of A and input of B and input of N. Okay, so whatever input we are taking here, that will be taken as the string type. Okay, the type of that input will be of string, but we need to have the calculation here, right? So we need to change the type of that. So I am going to change the type. So A will be what? We are going to have a float type. You can have the integer type also, but I can use it for 0.5, 0.6 also. So that's why I am using the float type. Okay, similarly I am going to change it with for B also. Okay, and now number of turns, number of iteration. So number of iteration will be in integer type only. Okay, we will not go for the decimal or fraction portion. So we are going to have define the type as integer. Okay, so now let's check for the execution of this. So I'm going to run this cell. Now it is asking for the first approximation root. So suppose the first approximation root is 4.